Why is welding brittle materials so difficult? Imagine trying to bend a piece of glass or ceramic without it cracking or shattering. That's exactly what welding brittle materials feels like. These materials are tough to work with because they don't bend or stretch like metals do. Instead, they tend to crack or break suddenly when stressed. When you weld these materials, you are heating and cooling them rapidly, which adds more challenges. The heat causes parts of the material to expand and contract unevenly, creating internal stresses. These stresses can lead to cracks, especially in the heat-affected zone where the microstructure changes. Brittle materials like glass, ceramics, sapphire, silicon, and some high-strength steels resist plastic deformation, meaning they can't stretch or bend without fracturing. This makes controlling the welding process tricky because even small imperfections or residual stresses can cause cracks to grow quickly. The composition of the material also plays a role. Elements like carbon, sulfur, phosphorus, and hydrogen can make materials more brittle. Grain size matters too. Finer grains usually lower the temperature at which a material becomes brittle, but welding can cause grains to grow larger, increasing brittleness. During welding, microscopic defects or residual stresses often form at the weld joint, acting like tiny cracks ready to expand under stress. Temperature sensitivity is another factor. Many brittle materials become even more prone to cracking at lower temperatures. When cooled, they shift from ductile to brittle failure modes. Materials with high thermal expansion coefficients can warp or crack because they contract unevenly during cooling. To address these issues, specialists often use techniques like laser welding, which applies precise heat with minimal mechanical disturbance. Preheating the material before welding and applying post-weld heat treatments can also help reduce internal stresses and microstructural changes. Understanding these factors is key because improper welding can create weak spots that lead to sudden failure. These failures often happen at the welds due to the combined effects of brittleness, residual stress, and microstructural changes. Recognizing why brittle materials are so sensitive during welding helps us see why it takes careful planning, specialized techniques, and experience to get a strong, crack-free weld.